All right, in this one, we have the product of two transcendental functions. Transcendental functions means that no matter how many times you take the derivative, it has another derivative. It keeps going. So we're going to utilize a trick here. That's very helpful when you have this sort of thing. So I'm going to let u equal the e to the x term, and I'll let dv equal cosine x dx. Okay, and so we're going to use integration by parts for this one with these substitutions. Okay, and so my du is going to equal e to the x dx, and my v, the integral cosine, is of course sine x, not dx. Okay, so this is going to be uv, so we're going to get e to the x sine x, okay, minus the integral of v du, so e to the x sine x dx. Okay, and following the same trick, I'm going to let u equal e to the x. My dv is going to equal sine of x dx. du is going to be e to the x dx, and v is going to be negative cosine of x. Okay, so I can replace this then with this remaining result. So carrying this down, you have the integral of e to the x cosine x dx equals e to the x sine of x, that's this term, okay, minus, now I have u, v, so I have these two, so I have e to the x negative cosine of x dx, and then, not dx, sorry, not dx, and then I have, so that's the uv term, and I have minus the integral from 0, no integral, the integral from v du, so that's going to be negative e to the x cosine x dx. Okay, and you'll notice here that the negative and the negative make this a positive term. Okay, but then I have another negative out here that I will distribute back through, so let's go ahead and do that. So we have e to the x sine of x, negative and negative make that a positive, e to the x cosine of x. Trying not to lose you there. Okay, and then over here I have a negative going back through to make that a positive into another negative, so it's going to be minus then the integral of e to the x cosine of x dx. Okay, and now it looks like we're going to have to do parts again, but if you're clever and you notice that you have e to the x cosine x right there, and our integral is also e to the x cosine x right there, so I have the same thing on both sides, so I'm actually going to add, instead of continuing on using integration by parts, I'm going to add e to the x cosine of x dx to this side, and also I'm going to add it over to this side as well, so plus e to the x cosine x dx, which in a sense gives me two of those, and so I have two of those. These are going to cancel out, and I'm left with this term here. So these two are going to are additive inverses, so they're going to give me the identity of 0, and these two are going to give me 2, so I have 2 times the integral of e to the x cosine of x dx is equal to e to the x sine x, that's this term, plus e to the x cosine x. Okay, and so finally then, to solve for this integral, I just need to simply divide both sides by 2. And so this seemingly difficult integral, using integration by parts, allows the integral to show back up, and so I can remove having to do the integral by adding it to both sides, and then that gives me a closed form for this side. I am missing a plus c as a constant term from the multiple integrations, but that gives me then the closed form for that integral. So whenever you have a product of transcendental functions, this method is a really helpful trick in being able to get the area of the integral, or the value of the integral in closed form. Okay, I hope that was helpful, and I'll see you in the next video.